Yeah. Good evening, students. It's once again, great, to have all of you on board. So for our Igniting Young Minds class for physics, so we are continuing. So last class, all of you had asked for, kinematics because, நான் initially start பண்ணது வந்து units and dimensions. So இப்போ வந்து நம்ம kinematics பார்த்துட்டு இருக்கோம். So last class, we discussed few formulas, important concepts.
Manish, you
We'll
can
have.
try to speak in English because one or
It's
two
okay.
North Indian students are also there.
Okay, fine. I was doing a mixing and blending approach, but it's fine.
Yeah.
Okay. So we'll be looking at kinematics for today's, session. So that is what is being planned. Okay. Initially, we started off with units and dimensions. Now, to be inclined with the curriculum that is being taught in schools, that is in your, school. So we are also trying to bridge the gap. So we'll be doing kinematics in today's lecture. Okay. So that is what is planned for today. So we'll look at it. We'll quickly brush up certain basics, some concepts, and then we'll jump into the questions. All right. So we'll look at it, children. So here we go. Just confirm if you guys are able to see what I'm annotating on the screen. Okay. So there might be a delay, but you should be able to see it. Okay. I'm just writing kinematics. I hope you are able to see it. Yeah, it's visible to all of you. Okay. So this is the title for today. So we'll be looking at kinematics for today. Fine. Now, what do you mean by kinematics? Let's have a quick, understanding of this term. So, in a nutshell, kinematics is defined as, it is a branch in physics which deals with motion of objects without considering the cause of motion into account. I repeat, it is a branch in physics which deals with the motion of the object without taking into cause the motion into the account. So we deal the motion of any particular object without taking into account the cause which is going to create the corresponding motion. So that is the basic subtle definition of what kinematics is all about. Okay, so we'll now move in to the concepts. So the first core concept that we are looking at. So some of the concepts you guys might be familiar with. So it will be a revision or a quick recap for you. So first one is basically the condition of rest. So you need to understand what is meant by rest. When you say an object is at rest, okay? So rest is basically the case where the object is stationary. So when an object is stationary, it is at rest. Okay? So when you say an object is stationary, that means there is no motion. Then you say the object is at rest, which means the velocity of the object is totally zero. So the initial velocity is 0 meters per second. If this is the case, then you say the object is perfectly at rest. Fine. Second, the object being in motion. So when you say the object is in motion, you say an object is in motion if there is certain velocity associated with the object. Okay, so when an object is moving, it changes its position with time. So when an object changes its position with time, then it's in motion. Okay, then you say the object is in motion. So this is the idea about motion. So for condition for motion is when an object is said to be in motion if it changes its position, and the condition for this is the velocity is not equal to 0. So there is a certain value, there is a finite value for velocity. So when velocity is not equal to 0, then you say that object is in motion. So these are two basic ideas. Okay. Next, we look at the basic concepts. So moving on to the next one, the third concept for the day. What is meant by speed? So these are simple terms. So when you say object is moving with certain speed, or what is speed basically? So speed is defined as the ratio of distance traveled upon time taken. So in simple terms, we can say speed is equal to distance, which is d, upon time, which is t. Okay, these are the symbols for distance and time. So in simple formula, you can write d upon t, which is distance upon time. And what about its unit? Distance would be expressed in terms of, I hope you guys might be knowing, we represent distance in terms of meters and you express time in terms of seconds. You combine both, you will get meters per second, and that's the unit of speed. Okay, so that's about speed. And now we move on to the next aspect. So these are all simple aspects. So we'll proceed further. So speed, the ratio of distance upon time, units, meters per second. Similarly, velocity. Velocity is basically the displacement of an object in a particular specific direction. So you can simply say velocity as the ratio of displacement. Displacement is expressed using the letter S. So it's displacement upon time. Time is always in seconds. Okay, so it is in T. The symbol is T for that. Just write it here. So time is expressed as T. So you can simply write it as S upon T, where S is displacement and time is in seconds. So again, the units, displacement is going to be in meters and time is going to be in seconds. So therefore, the unit for velocity is same as speed, which is meters per second. So both of them have the same standard units. Okay, so we are done with velocity. So we'll move on to the next part. We have something called as acceleration. Okay? Acceleration is defined as the rate of change of velocity, which means you can write it as the ratio of change in velocity upon time. So change in velocity upon time is expressed as acceleration. And what is its formula? Change in velocity can be written as delta v upon t. So delta v, you can see that delta is a triangle symbol. And what does it symbolize? What does it signify basically? Delta means change, change in. That is what it means. So change in velocity is basically delta v. Okay, this term stands for change in velocity. Okay, so change in velocity upon time. Now, what is the formula for change in velocity? How can I write delta v? So change in velocity is expressed as the final velocity minus initial velocity, which is v minus u. That's the formula for change in velocity. Okay, so here v means final velocity and u is initial velocity. Okay, so that's what change in velocity is all about. So therefore, you can write the formula for acceleration as a equals v minus u upon t. This is the formula for acceleration. What about its unit? How do you find out the unit of acceleration? Let us see. You can see that on the numerator, you have velocity terms. The unit for velocity is meters per second. We have just now learned. Divided by time is always in seconds. What happens post reciprocaling? Once you reciprocal it, you'll be getting meters over second squared, right? You can see that second in the denominator gets multiplied with the second on the numerator on the top. So you ultimately get meters per second squared, and that's the unit of acceleration. Okay. Next, we'll move on to the sixth concept. So we're done with acceleration, which is the rate of change of velocity. So v minus u upon t. This formula is delta v by t, and then the unit is meters per second squared. With that, moving on to the next concept, which is average speed. Okay. Average speed. Formula for average speed can be expressed as total distance traveled upon total time taken. Total distance traveled by total time taken is the formula for average speed. So the ratio, you can simply say its definition as the ratio of total distance traveled by an object to the total time taken to cover that distance. So that's what average speed is all about. So total distance traveled we can express using capital D upon T. So that makes a formula for average speed. And what about its unit? Again, the unit is going to be in terms of distance is in meters, time is in seconds. You combine them, you will get meters per second. And that's the unit of average speed. All right. So we are moving on to the next aspect, okay, which is average velocity. So we'll see what is average velocity. Unlike average speed, average velocity is the total displacement upon the total time taken. So you can write it as total displacement of an object upon the total time taken. That's it. So that is the formula for average speed. So again, expressing in terms of symbols, total displacement, you can write it as S upon time, which is T. So we can say S total. ST represents, the suffix T represents total displacement. Okay. And what about its unit? Again, displacement is in meters, unlike time is also in seconds. You combine both, you will get meters per second, and that's the unit for average velocity. Okay. Next, moving on to the next concept. We have a physical quantity called as momentum. Okay. Momentum is expressed by the letter P, capital P. So what is momentum? Momentum is basically the combined effect of mass and velocity of a moving body. So let me just write it here, the definition first. So we express momentum as the combined effect of mass and velocity of a moving body. So that's basically the aspect of momentum. So if you want to write it mathematically, you can express momentum P as the product of mass times velocity. And this is the formula for momentum. Is that clear? So momentum is the product of mass and velocity. What would be its unit? Mass is generally in kilograms and velocity is in meters per second. And you combine both, what do you get? You get kilogram meters per second, and that's the unit of momentum. Okay, so momentum, I repeat, is the product of mass and velocity, and the standard units for momentum is kilogram meters per second. So we are done with momentum as well. Now we'll move on to the next aspect. Okay, so we have equations of motion. So we'll be learning the equations of motion. Next, we have three equations of motion. So I'll teach you equations of motion as well. So we have first equation of motion. We have the first equation of motion, which relates final velocity, acceleration, and time. So first equation of motion, you need to keep in mind which it relates: final velocity, acceleration, initial velocity, and time. Okay, so let's see what is the formula for the first equation of motion. So V equals U plus 8. That's the expression for the first equation of motion. So you can clearly see it's a velocity time relationship. In simple, you can say it's a velocity time relation. So see velocity and time, you have both of them. And then you have the second equation of motion. We'll see that as well. The second equation of motion. What does it relate? Let's see what are the physical quantities that second equation of motion relates. So it relates displacement and time relationship. So you can say, we write it as S equals ut plus half at squared. So that's the second equation of motion. So we can say it's a displacement time relationship. Okay, second equation relates displacement and time relation. So this is the second equation of motion. And then we have the third equation of motion. We'll see that as well. The third equation of motion is expressed as v squared minus u squared equals 2as. So this is the third equation of motion. And what does it relate? As you can see, it relates velocity and displacement. So it's a velocity displacement relation. You can also identify what is the difference between the three equations of motion. Especially the third one, you can see it's quite unique and different from the first two. In what ways is it different? The first two equations share a common similarity. Can you see that time term comes in both the first and the second equation? So the first two equations are basically dependent on time, which means time is a required aspect to calculate the first two physical quantities of velocity and displacement as far as the first and the second equations of motion are concerned. But look at the third equation of motion. It is independent of time. In certain cases, when you solve questions, you may not have time, but you may obviously have the displacement and velocity, or you may have displacement and acceleration. So in that case, using third equation of motion would be a wise choice. So based on the given data, you will have to wisely choose which formula would be a perfect choice to solve your question. Okay, so that's something that you will have to keep in mind. So here, the third equation of motion is independent. It is independent of time. That means it does not have time, okay, as a variable. So with this, we cover three equations of motion. Let's have a quick recap. The first equation of motion is a velocity time relation, as in v equals u plus at. The second equation of motion is a displacement time relation, as in s is equal to ut plus half at squared. And the third equation of motion is independent of time, wherein you can't find the time term. It's a velocity and displacement relation. So like this, we have three equations of motion, which are the important pillars to solve many questions, many numericals in kinematics. Okay, so with that, we'll go to the next concept. The number is 9. We'll look at the ninth concept. Okay, so what else do we have? We have some more relations also. I'll give you, two more relations. Okay, which is also necessary. These are extended equations which are useful for competitive exams. Okay, so the extended formulas are, so I will write extended kinematic equations. We have extended kinematic equations. So the extended, that is the fourth kinematic equation, or the fourth equation of motion, is given by the relation. We say it as Sn equals u plus a by 2 times 2n minus 1. Okay, what is Sn here? We know that S is displacement. Sn is basically the displacement of an object in the nth second. Displacement or distance, okay, it depends on the question. So Sn represents, in general, I'll write it as distance. So it is a distance, or you can say displacement. We'll express both distance or displacement of an object at the nth second. At the nth second. So that is what Sn represents. You know what is u and a, and n is nothing but the nth value. So n is your integer. Okay, it can be integer or it can be also a fractional value. It depends. It can be integer or even a fractional value. So it can be a value, any particular value at the first second or the first 1.5 seconds. Okay, so any particular value. So n is a general value, a numerical value, as in an integer or a fractional value, but no irrationals. It's only rationals, integers. Next, so this is the general expression for the fourth equation of motion. And finally, we'll see the fifth equation of motion. This is also an extended equation, which is important. It gives you a comparative edge. So fifth equation of motion. So this is expressed as S equals U plus V upon 2, the whole into T. So this is the fifth equation of motion. So it's purely, you can see, it relates displacement, velocity, and time. So it's a displacement time relationship. So another way of expressing it. Okay. So it's again ST relation, which means displacement time relation. And the previous one was, you can see, it's displacement and acceleration relation. So displacement SA relation. It is used for finding out the distance or displacement of an object at the end of nth second. So n can be any particular value except irrationals. These are all the kinematic equations. We have three basic kinematic equations plus two extended. So totally you have five kinematic equations, okay, including all of them. Fine. So with that, we'll move on to the next part, the next aspect. Okay. So the number is 10. We have equations of gravity. Now, just unlike how we had equations of motion, we also have equations of gravity or gravitation. You can call it equations of gravitation. That would be much better. Let me just reframe or rephrase it. Equations of gravitation. Okay. So let's see how to convert our equations of motion in terms of equations of gravitation. Let us see how to do that. Okay. First, the first equation of motion, B equals U plus AT. Second equation was S equals UT plus half AT squared. Third equation of motion is V squared minus U squared equals 2AS. So we have learned three equations of motion. So now we are going to map them, we are going to convert them in terms of equations of gravitation. So what I've written here is basically equations of motion. So now we are going to map them in terms of equation of gravitation. So when I say equations of gravitation, there are two aspects. First one, the object in free fall. So when an object is in free fall, what happens? Let us try to investigate. So let me take an object having some mass. So I'm taking a ball here. Okay, it has some mass and I'm dropping it from point A. this ball is dropped from point A to the surface of the ground. This is the ground surface at the bottom. So when I drop the ball, you can see that the ball is going to fall down and it is going to reach final position B, and the distance that it travels, let me take the distance as h. So h is the height from which it is being dropped. Then I say that the ball is in free fall. So here ball is in free fall. What do I mean by free fall? When the object moves purely under the influence of gravity, you call it as free fall. Okay, you are not giving any external force as such. You are just releasing it from a certain height. So the motion of the ball is purely under gravity. Okay, and you can see that ball falls in the direction of gravity. So for such cases, it's important to know that you will replace acceleration as acceleration due to gravity, which is g. In the place of a, you would substitute g, and in the place of s, you will substitute h, because the ball is falling through a height. So displacement term needs to be replaced with height. And now you can transform the equations of motion in terms of equations of gravitation. So the first transformation will look like when I say v. Once the ball falls, you know that it is going to be released. So initial velocity is going to be 0. So I will take u as 0, but v is not equal to 0. Why? Because the object is going to strike the ground. It's going to impact the ground with certain velocity. So final velocity is not 0, but initial is definitely 0. Even before you release, there is no velocity. So u is 0, but v is not 0. So the first equation of motion gets transformed as v equals u is 0. So I'm not writing it. In the place of a, I will write g, and t is the time taken to reach the bottom. So v equals gt is the first equation of gravitation. Similarly, what is the second equation of gravitation? How will you transform it? In the place of s, what would you do? You substitute height but through which it is dropped. So in the place of s, you substitute h. So h equals, initial velocity is 0 as I told you. So ut is going to be 0 anyways. So you would get half g t squared. And that's the second equation of gravitation. I hope it's clear. This is how you transform. And what about the third equation of gravitation? You would get this as v squared is equal to 2gh, wherein v equals under root 2gh. Okay, so this is the third equation of gravitation. So we have now found out the three equations of gravitation for an object in free fall. So we have investigated an object in free fall, we wrote its conditions, and we have transformed the equations of motion in terms of equations of gravitation. Okay, so this is what we have written. So let's have a quick recap. Equations of gravitation for an object in free fall. So there are three equations. The first equation was P equals gt. Second equation was h is equal to half gt squared. Third equation was v equals under root 2gh. So you have, these are the three equations of gravitation. Okay. We have successfully derived the three equations of gravitation by transformation method. Okay. Now we move on to the next aspect. What if the object is projected vertically upwards with some velocity? So we are going to write the equations for them as well. Okay, so you just see the next number 11. Okay, next, the equation of gravitation when an object is projected vertically upwards with initial velocity. With initial velocity. So when you're trying to project any particular object vertically upwards with some velocity, now let us try to investigate this corresponding case. So imagine this is the ground level. Okay. Now I'm taking an object, say I'm taking a ball and I'm trying to throw it up from the ground level. So this is the ball. The ball is initially at this point, say this is point A. Okay. I'm projecting this ball in upwards with a velocity. So let me say this velocity as u. So there is some initial velocity with which I am projecting it vertically upwards. Then what happens after some time? After some time, the ball is going to reach a certain height. Okay.
Sir,
Yeah.
sir, the screen is not visible for us, sir.
Okay, I'm sharing the screen. How come it's not visible? It is being shared. Please check. You're not able to see it?
Yes, sir.
No, Manish, if they have joined later, they will have
Uh-huh.
problem. You can again you can stop presenting and then again you
Okay,
can
let me try resharing.
yeah reshare. Yeah.
Yes. So I'll reshare. Just
See,
check
that is the
now.
problem with people who join late. No, you should join in time. 7:30 means maybe by 7:35 you should be here. If you join late, this kind of problems will come.
Yes. Could you please confirm if you're able to see the screen now? Because I've reshared. The problem solved. Yeah, I hope you should be able to see it.
Yes, sir.
Yes. Yeah. I hope it was it Varshini or Anushri?
Sir, I can see the screen.
Okay, okay, fine, fine, fine. You're able to see it now. Fine. Okay, so we'll continue. Fine. So whatever is it, let us know in the initial phase itself, because as we cover, you'll be losing the concepts. So ensure that the screen is visible to you. In case if it is not visible, please let us know well in advance. Okay, need not wait until the last minute. Okay, so now we are moving on to the next concept. So when you have an object, okay, here I've taken a ball. It is initially at point A, and I'm projecting it vertically upwards, which means I'm throwing it vertically upwards with some velocity. So after some time, this ball is going to reach point B. You can see B is at a certain height from the ground, right? So the height from the ground, let us take it as h. Okay. So here you need to understand initial velocity is not zero, but final velocity at a certain height, that is at this point B, becomes zero. The ball is going to reach the certain height. Okay, at that particular height, when you throw, and it has gone to that particular height, so the velocity at that height becomes zero. Okay, at an instant, and then it starts falling down. So therefore, when an object is projected vertically upwards, you need to understand initial velocity is not zero, but then final velocity is ultimately zero at a certain height. Okay, after it is being thrown. So therefore, we again transform the three equations of motion for this case when object is projected vertically upwards. So again, let me write the equations of motion which already we have learned. The first one is v equals u plus at. The second equation, s equals ut plus half at squared. And third equation, v squared minus u squared equals 2as. Okay, so these are the three equations of motion. Now let's begin the transformation. Now when you're throwing an object vertically upward, we understand that initial velocity is not zero, but final velocity is. Okay, and also additionally, when you throw an object vertically upward, don't you think the object is going against the gravity of the earth, right? So because its motion is against the gravity of the earth, you will take A equals minus G. Why the negative sign? The negative sign indicates the motion of the object is against gravity. Gravity always tends to pull objects towards the earth. But when you're throwing an object away from the earth, so you're doing work against gravity. So you need to substitute negative G in the place of A. Okay, this is something that you will have to keep in mind. It's an important relation. Okay, and then in the place of displacement, that is H, that is S, you will substitute H. So now let's begin transformation. So transforming the first equation of motion, V is 0, so 0 equals U minus GT. So what happens to U when you rearrange? You will get U equals plus GT, and that's the first equation of gravitation when you throw an object vertically upwards. What about the second relation? What happens to that? In the place of S, you can substitute H. So H equals ut minus half gt squared. Okay, so that's the second equation of gravitation for this case. And the third one, you know that final velocity is 0, so minus u squared equals minus 2gh. On both the sides, you can cancel out the negative terms and you can get rid of the squared by taking root on both sides. You will get u equals under root 2gh. That's the third equation of gravitation for this case. Okay, so we have successfully transformed the equations of motion to the equations of gravitation when an object is projected vertically upwards with some initial velocity. So the conditions that you need to apply is initial velocity is not equal to 0, displacement equals to h, acceleration is equal to negative g. I told you the reason why, because you're throwing the object vertically upward, it's going against the gravity of the earth and hence the negative sign. And final velocity is going to be 0, as eventually the object would reach maximum height, and at that height final velocity becomes 0 for a particular instant. Okay, so this is all the equations of gravitation when an object is projected vertically upward with some initial velocity. So let's have a quick recap for this also. So the equations of gravitation. So equations of gravitation when an object is projected vertically upwards with initial velocity. Okay, so with initial velocity, then what happens? We have learned three equations. The first one was u equals gt. Second, h is equal to ut minus half gt squared. And third is u equals under root 2gh. So these are the three equations of gravitation for the object being projected vertically upward. The equations of gravitation when an object is projected vertically upward. So in total you have 3 plus 3, which are 6 equations of gravitation. Okay, for both the cases combined. All right. So next, moving on. I hope this aspect is clear. Fine. So with this, we'll move on to the next aspect, the next concept. Okay. So we look at the 12th concept. Okay. Now we have graphs. Okay, so we look at graphs now. So graphical representation of motion. So we look at the graphical representation of motion of objects. So we look at that. Okay. So the first aspect, the first graphical representation of motion, let us see. Okay. The first type of graph. Okay, we have different types of graphs here. So here we're looking at the first one. Okay, let me use a alphabet character. So A is the first one, the first type of graph. Okay. So we look at position time graphs. Okay, position time graph. So here in position time graph, position is taken along the y-axis and time is taken along the x-axis. Okay, so always time is on the x-axis. So keep that in mind. So x-axis is exclusively for time. So we express the graph, position time graph, by using graphical method. So different aspects are there. Okay. So under this we will see the first category, the first type of position time graph. So if the position time graph is like this, so here you have the position. So position is represented using the letter X. Okay. So you have X and you have T. X is along y-axis and T is along the x-axis, as you can see. Okay. So now say my graph, my position time graph is like this. If the position time graph is a line that is parallel to the time axis, what does it imply? Or what is the meaning for this graph? It means that the position is constant. Can you see? There is no change in position as time changes. Basically, the object is at rest, isn't it? Because you can see that there is no position, there is no change in position with time. So this graph represents object at rest. You know that when object is at rest, the velocity is zero. So v is totally equal to zero. That's the condition. There is no change in position. The second type of position time graph is this. So you have position along y-axis and time is along x-axis again. Suppose if I have a graph like this, then what does this type of graph represent? You can see that this graph is a linear graph. The position is changing linearly with time, right? So therefore, there is equal change in position with equal intervals of time. That is what it means from this particular graph. There is a linear relationship. So here the object is in motion. To be more precise, it is in uniform motion. Why is it in uniform motion? Because it changes uniformly with time. Okay, the position changes uniformly with time. So therefore, the object is in uniform motion. And there is a particular specific speed or specific velocity associated with the object because it's changing changing its position with time. Okay, so that is the second category. Moving on to the third category, third type. So again, taking position along y-axis and time along x-axis. What if you have a graph like this? Now this is not a linear curve because you can see it is curved upwards. Okay, such curves, we call them as hyperbolic curves. It's a hyperbola. So where you can see there is a steep increase in position. There is a sudden increase in position for even a small duration of time. It's an exponential graph. So such graphs denote that object is in non-uniform motion. That's the first important aspect. So here the object is in non-uniform motion. Okay. As the position is not changing uniformly with time. It's not a linear relationship. It's a non-linear graph. Therefore, the object is in non-uniform motion. Okay. So for uniform motion, there are certain points that you should keep in mind. So for uniform motion, you know that the object is going to travel equal distances in equal intervals of time. Okay, so we'll see that as well. So that is basically the definition of what uniform and non-uniform motion is all about. Okay, so these are the three different types of position time graph that you will have to understand. Okay, so we have now dealt with position time graphs. Okay, so we have seen different categories of position time graphs. So with that, we'll move on to the next type of graph, rather the second type, which is
Manish, one
displacement.
interruption.
Yeah, yeah,
These graphs are very important for our competitive exams. I've
yes,
seen
yes.
this umpteen times in many of the exams. So students, you just keenly observe, and he's taking very nicely. In fact, I am learning from your class today. Okay,
Okay,
even though I know the subject, but I am learning from the some of these basic understanding is getting better for me. Okay,
okay.
thank you, thank you.
Yeah, yeah. Okay, well good. So ensure that children, you are making a note of all this. Anyways, I'm going to send the notes. That is not an issue. But still, writing is something important. So if you write, once, it is very useful because you something goes into your mind. You know, so writing is something that you will have to do it. So maintain a separate book. I would recommend that highly. So and write down the points which we are discussing. Okay. So we are moving on to the next category. So position time graph is now done. So we are moving on to the displacement time graph. So we'll see what are displacement time graphs. Okay. What are basically meant by displacement time graphs? Now for this we need to understand the subtle concept of what displacement is all about. Displacement and distance travel, or often students have a misconception with whether both of them are same or both of them are different. Okay, so both of them are totally different. The perception of displacement is totally different than what distance travel is totally is. So displacement, in short, you can say it is the shortest distance between the initial and final point. Okay, the initial and final position of an object during its journey. So this is displacement. I'll give you a quick example. Say Rahul starts from point A. Okay, so I'm representing Rahul using a dot here. Fine, he starts from point A. Now Rahul is traveling 5 kilometers due east. Now what do I mean by 5 kilometers due east? That means, as per geographical directions, we know what is north, south, east, and west. So north is upwards, opposite to it at the bottom you have south, to the left you have west, and to the right you have east. When I say Rahul moves 5 kilometers due east, you need to understand that he's moving towards right and he's reaching another point that is towards east, that is towards the right from his position. Okay, so he reaches a point B. Now, what is the distance between A and B? It is 5 kilometers. Okay, because he moved 5 kilometers. Similarly, further he is moving. Further, Rahul moves, say, 3 kilometers due south. Okay, Rahul is further moving 3 kilometers due south. So he reaches another point C, which is towards south. So say this point is C, and the distance between B and C is 3 kilometers. Okay, so this distance is 3 kilometers. Now the question is, what is the displacement of Rahul? He started with point A, this was his initial point, and C is basically his final point. Based on this data, you can identify what is the displacement. How do you, evaluate or compute what the displacement is? By definition, you can see that it is the shortest distance between the initial and final position. So how do you find out the shortest distance? You just need to draw a line between A and C, and that is the shortest path. So this here, if you draw a line joining A and C, a straight line, that's going to be the displacement of Rahul, right? And how can you calculate that displacement? You can take it as x, right? Can you see that it forms a right angle triangle? Opposite to x, you have 90 degrees. So x becomes the hypotenuse. So I hope you guys know how to calculate the hypotenuse using the Pythagorean rule. So you can write x equals under root ab squared plus bc squared, which is root over 5 squared plus 3 squared. Okay, 5 plus 3, which is root 25 upon plus 9. So how much is 25 plus 9? Root 34, correct? So you get under root 34. So under root 34 meters is basically the displacement of Rahul. So that is the displacement of Rahul basically. Okay. So like this, you can find out what is the displacement whenever you have a situation. So based on the given data, carefully analyze, and then you will calculate the displacement. What I gave is just a simple, question. You can have other versions of this as well. This is all about displacement. Okay. Now same thing, if I ask, what is the distance traveled by Rahul? What would be your answer? If you say distance traveled, so remember, distance traveled is the total path length traveled by an object. That means you take into consideration the path, the entire path the object has traveled. In this case, my object is Rahul. So he traveled from A to B, and then finally he traveled from B to C, right? To reach C ultimately. So distance traveled is equal to distance traveled by Rahul from A to B plus distance traveled by Rahul from B to C. That gives me the total distance traveled by Rahul, which is 5 plus 3 kilometers. You get the answer as 8 kilometers. Okay. Previous one is under root 34 kilometers, not meters. Okay. It's actually given in kilometers, so it's root 34 kilometer, and this distance traveled is 8 kilometers. Okay. So this is how you will compute distance and displacement. So both of them have their own meanings. Displacement is the shortest path between initial and final position of an object, while on the contrary, distance traveled is the total path length traveled by the object during its journey. So that's the difference between distance and displacement. Why I explained this is to avoid the misconception. Okay, that's the reason I explained with an example. All right. So with that, we'll continue with this displacement time graphs, which we were doing. So moving on with that. So trying to understand what are displacement time graphs. So let's see. Displacement, as far as kinematics is concerned, we use the letter S for displacement. So we will also stick on to the general notation. So we'll see the first category of displacement time graph. So here is the graph. So I'm drawing the graph. Okay, so displacement, as usual, you take it along the y-axis. Displacement is in meters, and time is in seconds. Okay. What does this graph represent? If I'm going to have a line which is straight, it's parallel to the time axis. Again, you can see that there is no change in displacement, right? The displacement is rather, it is same. There is no change in the value of displacement. So by just looking at the graph visually, you can conclude and you can say that object is at rest. Okay, so this particular graph represents object is at rest because no change in displacement with time. Okay, so there is no change in displacement. Okay, with time, and hence the object is at rest or the object is stationary. Second type of graph. Okay, so when I say the next graph, so again let me draw the graph. So as usual, the axis needs to be taken care, displacement time in their respective positions. And now you have a graph like this. Now you can see this graph is a linear graph. The object is traveling, or the object is covering equal displacements in equal intervals of time. Okay, so again it's a linear graph, we can say. So you take any particular points, 2 points, you can see it is going to be linear. Now here I would like to mention an important aspect. So it is the slope of the graph. Okay, so I'm going to introduce the concept of slope. What is slope, and how you calculate the slope, all that. So let me take these 2 points as A and this point as B. So there are 2 points I have chosen, A and B. Now what do I mean by slope of the graph? I hope you guys might have some information about slope. Okay, so I'll just teach you that. Slope, sometimes often referred to as gradient. Okay, both are one and the same, just they are called by different names. It's synonyms, both are synonyms. So what is slope and what is basically a gradient? Let's try to understand. A slope or gradient is, for any particular graph, is expressed as the change in y-axis upon the change in x-axis. So that is the formula for slope. This is also expressed as dy by dx. Mathematically, you express like this. It is in calculus we express, or in physics generally we express delta y upon delta x. That is change in y-axis upon change in x-axis. So the ratio of change of y-axis upon the change of x-axis would give you the slope of any particular graph, not just the displacement time graph. This is just an example. It can be for any particular graph. So the slope can be evaluated using this formula. Come on, let us see. Here you can see when I say change in y-axis for a displacement time graph, what do you understand? On y-axis we have displacement, that is quite evident. So it is displacement upon time that I am talking about. Okay, so on y-axis it is displacement, on x-axis it is time. Now ultimately the slope of displacement time graph denotes velocity. Why velocity? Because it is displacement upon time. The physical quantity denoted by the slope of a displacement time graph is displacement by time, which is velocity. So therefore the slope gives you the velocity. Okay. Now let us look at this. Let us analyze this particular graph with an example. So say I am having a displacement time graph like this. So we'll take the graph. I'll give you values also so that you'll be able to understand it much better. So let's take some values. So origin, it is O, it is 0, both the x and y coordinates. So let me take 2, 4, 6. On the y-axis, I am taking the values as 8, 16, 24. Okay, and now I'm showing the points. So let us look at the points also. First point, let me call it that point as A. Point is B. This point is C. So let us mark all the points. This is point A, this is point B, and this is point C. Okay, and not to forget the axis, important. So x-axis you have time in seconds, and along y-axis you have displacement in meters. Okay, this is all the information we have for the sample graph that I've drawn. Now, what is the slope for the region OA and slope for the region AB, for the region BC, for the region AC? Okay, let us try to investigate. Now I told you that slope formula is change in y-axis upon change in x-axis. Okay, now write down the coordinates for each and every point. Now come on, who can tell me the coordinates for origin? I think origin, everybody knows the coordinates, right? So for origin or O, it is 0, comma 0. What is A? What is the coordinates for A? X, comma Y. What is the x coordinate for A from the graph? It is quite very good. It is 2, comma 8, right? Yeah, 2, comma 8. Same way for B. The coordinate for B is 4, comma 16. You can see it, right? It's x, comma y. That's what I'm talking about. And for coordinate for C is 6, comma 24. Okay, these are the coordinates. Now we are going to write down. We are going to compute the slope for OA of the graph. So what is the slope for OA? Change in y-axis upon change in x-axis. Come on, let us see from the region O to region A. So x-axis, it is changing from 0 to 8. So what is the change? 8 minus 0. Okay, so 8 minus 0 upon change in x-axis is it's changing from 0 to 2. So it is 2 minus 0. x2 minus x1. y2 minus y1. That's what I've done. So y2 minus y1 upon x2 minus x1. Okay, which is 2 minus 0. And what's the answer? 8 upon 2 ultimately gives you 4 meters per second. And that's the slope for the region OA. Similarly, what do you find out the answer for AB? What is your observation? How will you write it? Again, y2 minus y1. Who can tell me the values for the numerator? Come on, give it a try. One of you can volunteer. Feel free, don't hesitate. Even if there's something wrong, I'm there to help you out. So change in y-axis for the region AB of the graph from A to point B. So y2 minus y1 would be 16 minus 8 upon 4 minus 2. And how much is that? 16 minus 8 is 8. So 8 upon 2 ultimately gives you 4 again. So it's 4 meters per second. And for BC, you again try it, you will again get 4 meters per second. For AC also you will get 4 meters per second. So what do you observe from this graph? Can we conclude that slope is constant throughout for this given graph, right? So by the values that you have calculated, it is quite evident that slope is constant. So as the graph is linear, you can see that for linear graphs, slope is always constant. This is an important point to be noted. So for linear graphs, slope is constant. In this case, for a displacement time graph, the velocity is constant. Okay, the velocity is constant at 4 meters per second for the displacement time graph above. Okay, so that is what you observe. Fine. So this is how you understand the displacement time graph, especially if it is linear. Now, if it is non-linear, it keeps changing. Okay, the value keeps changing. It's not going to be constant. Okay, for a non-linear graph. So next number, next alphabet is C. So let us see that. ST graph for an object in non-uniform motion. That is the displacement time graph for the object if it's going to be in non-uniform motion. So we'll see. So there are different aspects for this graph. So we look at the graphs. It can be of two, three types. Okay. First one is like this. Second one can be like this also. Third one, you can have the graph can increase immediately and then it can remain constant for some time. Then it can decrease. Okay, then it can increase higher like this. So this is also for non-uniform motion. So these are the three different types of graphs that represent non-uniform motion. That is displacement time graph for non-uniform motions. That's what we are seeing. So displacement always along y-axis and time is always along x-axis. Okay, so these are three different types of graphs that denote non-uniform motion. Okay, so that's about it. So the first two graphs that you see here under this part, in these graphs you can see that there is a sudden increase of velocity. Okay, there is a steep increase in velocity. So we can say it is, you know, exponential velocity graphs. So there is a steep increase. We can say it's a steep increase in velocity. A steep change instead of increase, you can say a steep change in velocity because it's not necessarily increasing for both of them. So we can keep it as steep change in velocity. The other one, there is a gradual change. There are ups and downs. It remains constant also for some time, and then again it increases. Okay. So that's about the different types of displacement time graphs. Okay. So now we have covered all the aspects of displacement time graphs. We have looked at different types. We have seen examples for having a better understanding. So with that, and here for the C part, I need to include one point. Here, velocity is not constant, right? Because it keeps changing with time. So an important point is velocity, or you can say the slope is not constant. Okay, because at each and every point you can see the slope is different. Okay, for the first two graphs. For the second graph also, for a particular region, it is going to be different. For the first region, it's different. Second region, ultimately, it is different. So like that, you can identify, or you can see that both the slopes or the velocities for the graphs are not constant. It keeps changing with time. As time progresses, that also changes. Okay. So with that, we finish displacement time graphs. Okay. So we have seen displacement time graphs, and now we'll see the next aspect. The third aspect, velocity time graphs. Well, velocity time graphs, along y-axis, you take velocity as the physical quantity, and along x-axis, you will be considering time always as usual. So time is along x-axis and velocity is along y-axis. The unit of velocity is meters per second, as you all know. So again, you can see this first graph. If I'm going to draw a line that is parallel to the time axis like this. Say it is parallel to the time axis. What does this particular graph represent? Anybody? If a graph, the velocity time graph is having a line that is parallel to the x-axis or the time axis. So is the object at rest or is the object in motion? Is it at rest or motion? It's a
Yes,
straight line. Yeah,
it is at risk. So,
it is at rest. Okay, fine. Okay. So you should not come to a conclusion like that because this is a velocity time graph. It's not a displacement or position time graph, right? Don't you think there is a velocity value here? Velocity is not zero. At this point, there is some value. It can be 5, 10, 15, whatever, you name it. Okay? So it is the object is moving with constant velocity. There is velocity. You cannot say that velocity is zero. You're getting my point. So at this particular point for this particular graph, velocity time graph, whenever you have a line parallel to the time axis, okay. So this particular graph, there is a value of velocity. So therefore, object is in motion. It is definitely moving. Second thing you should know in this particular graph is the object is moving with constant velocity. That is, velocity is constant. If velocity is constant, doesn't mean the object is at rest. It is definitely moving. That's the reason you have some velocity in the first place. Okay. So this is also a common misconception. Some students, by just looking at the graph, you take a quick decision. That's wrong. You'll have to analyze what type of graph is first given. Whether it's a velocity time graph or displacement time graph or a position time graph. Looking at the nature of the graph, will you decide whether the object is in motion or at rest? Okay, so never take decisions in haste. So analyze the graph, understand it, and then you will have to come to a conclusion. So in this case, velocity is quite evident. There is velocity. Okay, you can't deny the fact that velocity is not there. It's definitely there. It is a particular finite value, just it's constant. It's just the same velocity. Simple. The object is moving at a constant velocity. That is what this graph represents. Okay. So object is in motion. It is moving with constant velocity. Now, what about the acceleration of this object? Who can tell me the acceleration? Does the object have any acceleration or not? What is acceleration? The rate of change of velocity by definition, right? Is there any change in velocity for this graph, for this object? It is moving
no,
with the
sir, it's
same
not
constant velocity,
very
which means there is no change in velocity, even though the object is in motion, but the acceleration is zero. Why? Because no change in velocity, same velocity throughout. So acceleration is zero. Why it is zero? Because u is equal to v. That's why it's zero. When you substitute in the formula for acceleration, by definition, v minus u by t, the formula, because v and u are both same, they get cancelled, you get 0 by t equals 0. And therefore, acceleration is ultimately 0. So therefore, can we say if acceleration is 0, the object can still be in motion? Right? Yes, we can say that. So when acceleration is 0, the object can still be in motion. This is an example. This graph is an example for that. Can you give some real life examples? Say on a highway, you're driving your car with a constant velocity of say 30 kilometer per hour. Because there is no traffic, you're on a freeway. So you can maintain a constant speed, right? So that's an example of acceleration being zero, but velocity being constant. Okay. So these are the aspects children that you should keep in mind. Okay. Yeah. I'll just give me 2 minutes. I'll get back. I'm getting a call. Okay. Meanwhile, you can just go through it. Yes, children. So I'm back. So I hope this case is clear. So when you have a graph, okay, especially velocity time graph representing a line that is parallel to the time axis, there are three important aspects. First, object is in motion. Second, velocity is constant, it's not changing. Third, because velocity is constant, acceleration is zero because there is no change in velocity. So these are the observations for this particular graph. That is a velocity time graph. We have now discussed the first category, first type of velocity time graph. We have different types under this, subtypes are there. Okay, this is the first type that we have seen. Moving on to the next type, second type of velocity time graphs. So as usual, velocity along y-axis in meters per second, and you take time along x-axis, which is in seconds. Okay. So again, here what you do, I'm taking a graph like this, a linear graph. Now, what is your observation from this particular graph? You can see that velocity is linearly changing with time. And what does it literally mean? There is a linear change in velocity with time, right? That is quite evident from the graph. Okay. So such graphs, what are the important points? So let us see. First point is that the object is in motion. It is definitely in motion. Okay. Second, what is your you can see your value of velocity here. So here the velocity is changing equally with equal intervals of time. There is equal change in velocity, which means acceleration is constant. Okay, so acceleration is constant. Velocity is not constant here. Okay, here your acceleration is constant because the gradient or the slope is going to give you the acceleration here. That's the next point. Slope of velocity time graph always represents acceleration. For the previous graph, if you see, the slope is zero. You understand why it is zero? Because there is no change in velocity, isn't it? So it's ultimately zero, and that's the reason you got A as zero. Okay, that is your interpretation. So here in the next case, the slope of this graph represents acceleration, and acceleration is constant here. Okay, because velocity and time share a linear relationship in this graph. Okay, so these are your observations for the second type of velocity time graph. That's a linear velocity time graph. So with that, we'll move on to the next type of velocity time graph, third category. So you have a graph like this. This is an exponential graph, as you can see. So there is a steep increase in velocity along y-axis, and time is along x-axis. Whenever you see such a graph, there is a sudden increase in velocity with time. Okay, so this graph, the observations are object is in non-uniform motion. Previously it was uniform. Here it's non-uniform motion, and acceleration is not constant. Okay, so acceleration is not constant. Basically, it is exponential. You can see that there is an exponential increase in acceleration. So acceleration can be expressed as a function of time as a is equal to dv upon dt. So by using a mathematical function, you can express acceleration as the rate of change of velocity using dv by dt. So it can be any particular function. Okay, so you can express it like this. So this is what is the third category of the velocity time graph. Okay, where it's not constant, acceleration not constant, it is changing at each and every point, it's different because the gradient is different. Okay, third, slope or gradient keeps changing with time. Okay, keeps changing with time. So it is not constant, that is also a variable. All right, so this is the interpretation of three different types of graphs. So now we have learned the different types of velocity time graph. These are all the kinds of graphs, students, that you should be knowing. It's quite important. It plays an important role in competitive exams. You have various types of graphs. So that's the reason I have taken enough time and I've explained all the types of graphs in detail. We have looked at them, and we have ample questions based on graphs. Okay, it's actually graphical analysis that we will be doing in the next lectures. Also, we will look at different questions, okay, based on graphs. So here also, you need to understand there can be different questions, variety of questions that can come based on graphs. Okay, the graphs also play a significant role in the examination. So ensure that you're going through them. Okay, any doubts somewhere you're stuck, also you can ask. You can uh, clarify them. So we have covered quite a large parts today. Until graphs we have seen. Almost we are coming to the end of the chapter. 3/4 I have covered. Some more small concepts are left. That's it. Okay. So which we will wind up in the next lecture.
Yeah,
Yeah.
tomorrow we have class at the same time. Manish?
Yes.
Yeah, so all students, you please come. Very interesting. Basic concepts we have touched. It's there in the book, but then the way he explained is fantastic. Uh, Someone wants to join now.
Okay.
Very interesting. Anyway, okay.
Okay. Okay.
Thank you, Manish. I think
Yes, sir.
it's quite an eye opener for me also. Even though I know the subject, இருந்தா கூட இது
Mm-hmm.
it's something which it helped me to recall and reclassify many things in my mind. Okay. Hope
Okay.
I think
Okay.
all of you found it interesting. How is the class? Tatmadika, Varshini, and others. எப்படி இருந்தது அனுஸ்ரீ? எனிவே நீங்கள் என்ன
Okay.
பண்ணோன்னா உங்களுக்கு இதை ஒரு 1 or 2 days போய் மீண்டும் அந்த புக் எடுத்து இது பண்ணதுக்கு எல்லாம் நீங்கள் பார்த்துட்டிங்கன்னா மறக்கவே மறக்காது. நீங்கள் இதே ஒரு 10 நாள் விட்டு பார்த்தீங்கன்னா அது யூஸ் இல்லாமல் போயிடும். இப்போமே சொல்கிறேன், ஆன் த வித்தின் 24 hours அதை வந்து அப்படி கொஞ்சம் டச் பண்ணுங்கள், லேசாவது டச் பண்ணுங்கள். உங்கள் புக்கில் இதே
Yes.
தான் இருக்கும். சேம் திங் இட் இஸ் தேர் இன் த புக், பட் அந்த எக்ஸ்பிளனேஷன் இப்படி இருக்காது. அதனால பட் நவ் யூ கோ அண்ட் டச் த புக், யூ வில் அண்டர்ஸ்டாண்ட் இட்ஸ் ஃபார் பெட்டர். ஓகே.
Yeah.
ஓகேம்மா, தேங்க்யூ.
Okay. Okay. Bye bye, children. Take care.
Thank you, sir.
Yeah.
தேங்க்யூ.
Welcome.